In case 4, we shift gears to explore macrocyclization. Macchia supports this through a design strategy where we form a ring that spans across distant parts of the molecule. Here we start from the same reference molecules used previously, but this time we define the design task as closing the loop between two distant functional groups. With case 3, we begin with 3D structural information of a ligand-protein complex. But the key difference here is our design objective. Instead of replacing a scaffold or linking to fragments, we want to grow a fragment and form a macrocycle that connects back into the molecule. Now, just like in previous cases, we define our chemical constraint, but this time with macrocycle-specific logic. We choose two exit vectors, typically located at positions we want to connect from the ring. These are set manually based on retrosynthesis or spatial proximity in the 3D structures. Then we apply standard medicinal chemical filters, for example, Pace and Tox list on molecular weight, but with an additional constraint. The ring size must fall between 12 and 16 atoms to balance flexibility and synthetic trackability. Here's how it plays out. The first step that Macchia performs is starting from the first exit vector. Here, Macchia applies chemistry-driven fragment growing in order to create a new endpoint. Then Macchia will use this intermediate and will connect the new exit vector with the second exit vector defined by the user. In this way, Macchia will generate the final macrocyclic molecules. Now let's explore in Macchia how can you actually go through all the settings in order to get macrocycles as generated molecules. The first thing that we do is to set up our initial fragments and also the two exit vectors, in this case the bromine and the chlorine. After that, we enable macrocyclization here, and in this way Macchia will be aware that all the generated molecules, they should be macrocycles. After that, we also define certain physical-chemical constraints, such as maximum molecular weight of 650, and also we define the size of the ring. In this case, we input a minimum ring of 12 and a maximum of 18. We also ask Macchia to work with molecules with QED with a minimum of 0.3. Also, we define and we ask Macchia to work with a smart list of pains and tox, so we know that these substructures, they're going to be avoided in our resulted molecules. Then we went into the 3D structure-based settings. These settings are exactly the same as we visited in case 1. So in case that you need a refresher, I invite you to go to the video of use case 1. After we set up our reaction center, our product constraints, and also our reward function in the form of 3D structure base, we can visit the generated molecules by Macchia. So as you can see here, all the molecules that are generated by Macchia, they are macrocycles. And if we click, for example, in this molecule here, we can follow all the decision that Macchia took in order to start from your initial fragment and to give you the macrocycles. Once again, we're going to have different kind of scores as being a score and contact score, and then post-process one, like the retrosynthesis one, which is going to give you an idea of the synthesizability of your molecules. Then again, you can visualize your macrocycle inside docked inside the protein pockets and compare it to the reference ligand as well, and also to visually inspect all the interactions formed between the generated molecules and your protein.